All right, mathletes, here we are problem solving using trigonometry. Nice thing about this is it's a lot like our problem solving using Pythagorean theorem. We're going to kind of follow these steps. One, we always want to draw our diagram. We want to step 2 mark on the diagram are unknown angles or sides that need to be calculated. Okay, using x or theta. Okay, step 3 is locate and find where your right angle triangle is going to be. Step 4, write an equation and deciding on how you're going to connect between the angle and the two sides of for the trig ratio. Step 5 is solve. Step 6, write your answer in sentence form. Often when we're dealing with problems dealing with trigonometry and right triangles, we might be talking about angles of elevation and depression. So the important piece to know is the angle of elevation and depression is always taken from your horizon line or the horizontal line. That horizon line, so your angle of elevation is from an observer and it's looking upwards. Okay, that's your angle of elevation. The angle of elevation is from your observer, okay, and looking downwards. Okay, but always know that the line, your horizon line, always must be an adjacent side to the angle at which you're talking about. Okay, so let's look at an example here. This one's just dealing with a roof. Okay, so we're given a roof with a pitch of 16 degrees. Okay, we know the roof is 9.4 meters long. Okay, we want to find the length of the horizontal beam. So that horizontal beam is all the way across here. Okay, I'm going to call that y. Okay, so I'm looking for right triangles. Well, one property that we're going to use a lot with solving here is we're going to want to know that we can split isosceles triangles in half and create 2 right triangles. So my right angle I identify here. So I'm going to redraw my triangle. Okay, my right angle here. So if all the way across is y, I'm going to call this x. And I'm going to recognize if this is x, that y is equal to 2x. So to find my actual distance of the beam, I'm going to have to double what I find in this thing. I'm going to label my angle that I know. This is 16. I'm going to label the side that I know, 9.4. Okay, so now identifying my angle being here, okay, the side that is opposite my right angle is my hypotenuse. The side next to my angle, which is not my hypotenuse, is my adjacent side. I'm not really concerned about my opposite side here. So, which trig function deals with adjacent and hypotenuse? So again, I always like to write on the top of my paper, so, ka, to, ah. So I'm dealing with adjacent and hypotenuse. That tells me I want to use cosine. So I set it up. Cosine of my angle, 16 degrees, is equal to my ratio of sides. So I have x over 9.4. Again, I'm going to put this over 1. Okay, and I'm going to cross multiply. So I know my x, my unknowns in my numerator, so it becomes a multiplication problem. So I have 9.4 times cosine of 16 degrees is equal to 1 times x, which is x. So using my calculator, I do 9.4 times the cosine of 16. So I get 9.0. I'm going to round that to a 4. And again, this is equal to x. So to find the answer of the entire beam, since these are 2 congruent triangles, I know that it's just x and x, so y is equal to 2x. So y is equal to 2 times 9.04, which is equal to 18.08. Okay, so as I'm here, okay, again, I'm going to relate it back to the problem so I know I'm dealing with length. So this is meter. Okay. So Make sure when you're problem solving here, I always try and redraw a simple triangle. Label your sides as opposite, adjacent, and hypotenuse, your angles. Set up your trig ratio, solve it out, and relate it back to the story. All right, this concludes our notes tonight. Please highlight any questions you might have and bring them to class tomorrow.